Hello, everyone. How are you guys doing? I hope everyone's doing well. And yeah. All right, so let's jump into it. Um, Last lecture we set up Git, right? We set up Git, we set up Git fork, we set up GitHub, we set up a repository, we set up SSH or SSH keys. Um, right, which is great. We set up our dev branch, build branch, and master branch, and we pushed all these branches to the cloud, which is great. You can check out the you can check out the entire project over here. So RPG game. I should post this in the description. I haven't done that yet. I need to go through all the lectures and post resources. Um, I just I'm just lazy. That's all. All right. I so so this is just a request. Whoever is gonna go to the repository and gonna use it, do me a favor and start. That'd be really nice. It's like a like on what is it called? YouTube. So that'd be nice. And you can it kind of helps with the with discoverability in GitHub. It doesn't really quite matter, but it's whatever. It'd be nice, right? All right, so what am I planning to do today? Well, today I would like to cover movement and collision detection, hopefully, if we have enough time. So this is the plan for today. So we did the boring work. We set up GitHub, which is great. We set up our project and everything. Everything is kind of ready. And everything is waiting for us to just get started, right? So if I open my project right here, I need to go into debug mode. By the way, one thing I want to mention is that there are two types of errors or issues. There are errors, actual errors, and errors are things that you will have things. So okay, errors are issues that you cannot get around. So if I have an error, for example, if I forgot a semicolon, that's a syntax error. I can't compile my program. If I try to compile it, it's a fatal error. It will not let my program run at all. Right? So that's an error. A warning is it's like, hey, can you please fix this issue? If you don't fix it, it's not the end of the world, but if you could fix it, that would be really nice, right? So warning, you can run the application just fine if you have a warning. An error, you can't even compile it because there's a massive issue that you gotta fix. And you have messages, information messages. Now, I highly recommend you have this window at the bottom here. If you don't have it for whatever reason, if it's not open, you go to view, click on error list, and you have your error list. And I also recommend you have your output list. So again, view, output. And so you have both your error list and output. The really nice thing about the output list is that it shows you like the how many builds failed, up to date, successful, skipped. It shows you more information about what's going on. It's a little bit more clear and it gives you a lot more information than the error list. Now, what I usually like is to have my error list and output side by side. So if I click and hold my error output list, I can put it kind of on the side here. So now they're side by side. I like having it that way. One more thing. Do you see here where it says build plus IntelliSense? I really don't like having both build and IntelliSense errors. So I usually just go build only. IntelliSense errors, from experience, they can be sometimes stupid and hard to figure out. So we're just gonna go to build only. All right. So we have two warnings. Intermediate directory does not end with the trailing slash. The build instance will add the slash required. Okay. Whatever that means, sure, man. You do you. I'm gonna switch to debug mode. Keep it in debug mode. Debug is obviously much slower, but I can debug it and figure out what's going on. Now, if you don't know what debugging is going through the program and kind of trying to figure out what the issue is. So if there's an issue in my logic, I can debug my program. I can figure out what's happening in my program and fix it. So a debugger is a program that allows you to find issues and solve it, right? Debuggers are really powerful and they're really important, and we're gonna use them a lot. So in here, when I talked about, where did we do this? Oh, look at the difference between the size of this and the size of this. That's kind of cool. When we talked about here what we need to get started programming, I said we need a text editor, preprocessor, compiler, and assembler, and a linker. One more thing that I didn't mention is the debugger. So we kind of need a, let's put the debugger here, or let's put it here. Right, I think it's 2Gs. We need a debugger, right? And a debugger, again, is just a software that allows us to figure out what's going on in the code and kind of fix it if we ever have issues, right? So let's kind of zoom into our tiny world over here. All right, so here's what we're gonna do today. Today is a very exciting day. Today we're gonna jump into SFML and do more advanced things. What I want to do today is draw a sprite on my screen, right? Move it with my keyboard. You move it using my keyboard. So W to move forward, S, S is down, A, and D. So move it in all directions. Also move it diagonally. All right. So move it in all directions. Maybe have an enemy over here, also another enemy, and the enemy would just be standing still, and maybe we can shoot the enemy and kill the enemy. Something along these lines. I don't want to do a 3-hour lecture just like yesterday, because that was pretty exhausting. Not only for me, but I bet for whoever was watching that lecture too. So we'll keep it at like 1.5 hours. I think that's kind of a nice time, a nice ideal time for a lecture, right? All right, so let's jump into that and do that. So, going to the documentation, and again, it's really important you always have the documentation up and running and open, because you can reference the documentation and kind of see what's going on, and all that, right? All right, so documentation. So to draw a sprite, I'm gonna go to learn. And you can see here sprites and textures. So I'm going to click on that. And this is kind of my documentation on how to render a sprite or a texture, right? All right, before we jump into this, let's do some kind of, let me explain two things. What's a texture and what's a sprite? Well, a texture is basically an image, right? A texture is a box, texture, and this box contains pixels, a lot of pixels, a lot. Well, not a lot of pixels, I mean, depending on the texture, right? Let's say this is a 100 by 100 pixels texture. So px for texture, px for pixel, px for pixel. So this is the width. This is my height. So my texture is 100 by 100 pixels, right? And that means there are 100 pixels in a row and 100 pixels in a column, right? To make this a little bit clearer, let's do 50. So height, right? So my texture is now 100 on the width, 50 on the height, and always the width comes first, then the height. So when you do it this way, right? So that's what a texture is. It's literally a box of pixels. All right. So what about a sprite? What's a sprite? Well, in the world of SFML, a sprite can contain a lot of things. A sprite can contain a size. Let's start with the position. A sprite can have a position on the screen. It can have a size for the sprite itself. It can have a texture, right? An actual image on the sprite. It can have a scale. It can have a rotation, right? All of these things a sprite has. So a sprite, you can think of it as literally a box, and we apply this texture on the box itself, right? In my case, this box is a sprite. So we basically take this texture, this image, this raw image of pixels, and we apply it, we wrap it around this rectangle or sprite. And then we move the sprite. We move it using the position attribute or parameter or variable. We resize it, we scale it, we rotate it. We can do whatever we want with it, right? So a sprite it's a box that contains a lot of data like position, size, texture, scale, rotation, and a lot more. A texture is just an array or a box of pixels. Now I haven't explained what arrays are, right? I'll talk about that later. But yeah, it's just a box of pixels. For those who know what an array is, it's just an array of pixels, right? All right, cool. So that is that. So what I'm gonna do now is delete all this code, right? I don't need any of this code anymore. Delete all this. Hide my warnings because they're kind of annoying. And let's get started. All right, let's look at documentation. The first thing you need to do in the documentation is load an image, right? So that's the first thing we need to do. Well, before we do that, we need to have an actual image. So I'm going to search for a sprite. Not the drink texture or character sprite. All right. So you can see here. Let's take this. No. So I don't want to take this because it doesn't have transparency. And I said we're going to talk about transparency, and we're going to do that today. So transparency just means that there's a white background right now. This has no transparency because the background is white. This has no transparency, background is white. Background is white, no transparency, no transparency, no transparency. I think this is fake transparency, fake. Can we have a fake transparency? Perfect. Okay. This. Can I have a nicer? What is this? Ooh, this looks nice. I have an artist who's doing pixel art, which we'll add to this game. So that means you guys can have access to that. But for now, I'm just kind of looking for something kind of nice. I don't know. Okay, this is all actually horrible. Can we have pixel, pixel, pixel? So I'm looking for pixel art here. No, something nice, something cute. No, no, horrible. Pixel art sprite sheet. Okay, let me talk about about what a sprite sheet is. So a sprite is a single image, right? This is a single image. Well, usually we call it a sprite, even though it's actually a texture. Um, but in kind of outside SFML, a sprite is a single image. A sprite sheet is a big texture with a bunch of images for all of our animations. Um, so we'll cover that a lot in more detail later on. Please, anything. Give me something good. Horrible. No, I can. Why am I doing this? What am I doing? Okay. Um, free art. There, free art. Um, free pixel art. There was a website that I used to use all the time that has a library of free art. Free game development. Oh, it's called Open Art website. Open Cart? No, no, of course not. Open Art. Open Game Art? Yeah, this is the one. Okay, so Open Game Art. Uh, let's go to the arts. Anything good? Anything good? There's some cool art here. Next. You just need a character, please. Just oh, character. Go back. Are these good? These look fucking sick. Okay. I like you, whoever you are. I like you very, very much. All right. I'll put this in the description. So let me just put this. Let me just not forget to add this to the description of the video when this turns out to be a video later on. And for the stream, can I put it? Oh, I can put it in the stream. Cool. There we go. All right. Hello. Hey guys. I don't know what I did. What did I do? Cool. All right. Let me extract these. Uh, extract. Please be good. 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 PNG. Oh shit. That's a lot of work. Oh. Oh, these are all of them. Okay, so we can use that as the enemy. The character is just in multiple pieces. Can I just have the character on his own? I'd really appreciate that. Like all in one image. I don't want to slash. No, all of these are body. This is the skeleton. Why you give me person? You're supposed to give me a what am I examples? Okay, I mean this is kind of useless to me right now. I have no idea what XCF is. This is just a bigger PNG. Oh. Alright, well. I have to assemble him. Come on, I don't want to assemble him. This is supposed to be like a simple demo. Not do you have anything for me? Thank you, TQ. Um All right, this is cool and all, but you have to assemble them, and yeah, we're not assembling anything. Next. No, no. See if my artist was a little bit faster. Not throwing any shade or anything, you know. I'm just saying, if she was a little bit faster, and she didn't have a job and responsibilities, and she freed her all her time to do my art, we would have had this art already done. I'm not, you know, I'm not throwing shade or anything. Just saying. I'm just saying. Give me a character, please. Anything, for the love of God. Ooh, does this work? Is this good? This looks horrible. Need something a little bit nicer, please. I'm so picky. Are you good? No. Horrible. Next. Can I just filter out stuff? Submit. Can I just do character? Are you good? Look like. Um, this is not too bad. But I bet there's something better. SMH indeed. Next. No. Zombie. No. Mm, no. No. All I want to do is steal someone's art. Why is that so difficult? Is this ain't good? Please be good. You know what? At this point, it's decent. Whatever. It's a GIF. What am I gonna do with a GIF? Jesus Christ. No. 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 You know what? Fuck it. I will just use the skeleton. Skeleton seems nice. Alright. He looks prepared, ready for battle. It'll be the battle of skeletons. A skeleton killing another skeleton. That's how I'll do it. That's yep, so he can. Oh, that's a bow animation. Okay. Um can we have one for walking? That'd be nice. NG. Walk cycle, thank you. Alright. Just take this. Alright, so it's walking. This is fine, whatever. Can't you filter? I mean, I searched for a character, didn't find anything. Anyways, okay, so let me talk about transparency. This is really important in case for people who don't know what transparency is. All right, so do you see how if I open this image, my window, the color of my window is kind of bluish, right? Dark blue. And you can see that there's no white background. You can only see the character. This is the image. Let me get my epic pen. Epic pen. Get my epic pen up. All right, so this, whoops, this is kind of the image, right? You can see that there's no white background in here. You can only see the character. So that means that the background is transparent. There's nothing, there's nothing there, right? And usually transparency is indicated with this pattern. Transparency. Not that kind of freaking transparency. PNG. All right, so transparency is usually indicated with this pattern. When you see this pattern, white and gray, boxes, that means that this is a transparent image. Or sometimes in Google especially, you can find an image that's actually fake transparency, and what that means is this pattern is the actual background, and it shouldn't be like that. So you can see how this image is white, but if I open it here, you can see this is real transparency. In Google, this is a white background, but if I click on it, you can see the checkerboard pattern. That means that this is transparent. So now if I have an image behind it, I'll be able to see the image behind it, right? Like glass. Same thing here. This is a white background, and if I click on it, it'll give me a white background. Okay, so this is just a white background. This is another example here. This is a white background. If I click on it, there's the checkerboard pattern. Now, this is fake transparency because the image itself in Google, you can see the checkerboard pattern exists on the image. And I click on it, it exists in the image. If it's fake, the checkerboard pattern is here. If it's real, the image is white. When you click on it, you will see the checkerboard pattern. So that's just transparency. And when we talked about RGBA values, when we talked about pixels and RGBA values and all that jazz, would we do that here? PNG, no, yeah, here, over here, right? So we said that every single pixel has RGBA values, red, green, blue, and the alpha channel. And the alpha channel represents transparency, whether you can see the background behind you or not. So there, I explained alpha. All right, so this image, I'm just gonna copy it, gonna put it in a new folder. Just gonna show you something. So right now, this is a transparent image because you can see the background of the window, right? Now, let me make it not transparent. So if I copy this and paste it, and I open it in Microsoft Paint, Microsoft Paint does not support transparency. So if I open it, you will see that the background now is white. If I save this image and close it, you can see the difference, right? Let me make this view large. You can see that this image now is white. This is not transparent. Now this has a white background. But this image, this is transparent. You can see the actual window color, right? So that's kind of the difference. All right, so we're gonna take this image, gonna go to my SFML project, right click on my main.cpp, open folder container, go to assets. Assets is small a. I'm gonna keep it small a because when you change the capitalization of a folder, Windows is stupid, so sometimes you have to refresh it to kind of understand what's going on. So I usually like to keep things small letters. In assets, I'm gonna create a folder called textures. Actually, I'm gonna create a new folder called player. Inside my player folder, I am going to have textures. Okay, if I'm gonna make these capital, I'm also gonna make the assets capital. Never mind. I changed my mind. Look, it happens, all right? Don't worry about it. All right, so I have my assets over here. Inside is the player. The player has textures. The player has audio, or just called SFX or sound effects. Textures, yeah, that's all I want to have for now. So for textures, I'm gonna paste this image, right? And I'm just gonna call it what's it called? Spritesheet. Spritesheet. So this is what's called a Spritesheet. It has multiple images of whatever, right? All right, cool. Before I make this, okay, I want to do something. So I'm just gonna open this in Photoshop. Give me a second. Come on, Photoshop. Let's go. Come on, Photoshop. Let's go. Let's go. Let's go. Let's go. All right. Now, this image if you look at the dimension of this image, if I press and hold my Alt key on my keyboard and double click this, go to detail, this image is 576 by 256. So this is the dimension of my image. So we need to do some math here. So if I put this on the side, sure Photoshop. Can you open like a normal human being? Thank you. All right, so let's do some math here. What was the dimension? What were the dimensions? I forgot. It was 576 to, okay, 576 by 256. So these are the dimensions for my image, right? This is width, and this is height. Well, height. All right, cool. We need to do some math. We need to figure out. So we need to figure out how big is each skeleton is, right? This is the entire image, and when I want to render this, obviously, I'm not gonna render the entire image. I just want to render a part of it. So I need to figure out what every image is. From the looks of it, from what I can see, this is a 64 by 64 image, but we can be sure by doing one thing. So we need to figure out, we need to count how many skeletons are in a row. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 skeletons in a row. So 9 by 4, right? And a very simple math that we can do, divide this by 9, divide this by 4. So if I get my calculator and do 576 divided by 9, I get 64. So I was right. So this is a 64 by 64 image. But again, just let's do this math and just be 100% sure. But obviously it is 64 by 64 because it's a square image. So 256 divided by 4, 64. So now every single image here, right? Every single skeleton is 64 by 64 pixels. All right. And what I would like to do, I just want to render just one of them, right? So in Photoshop, I'm going to show you how to do it in 2 ways. The one that I'm going to do, which is not fantastic, and I'm going to show you a different way. So I'm just going to drag this into Photoshop. Come on, Photoshop, let's go. Right, this is transparency again. You can see this is this checkerboard pattern. All right, I would like this 64 by 64. So 64 is correct. Come on, there I go. 64 by 64. Copy this. Open a new, or just let's make a new layer. New layer. Click OK. Paste it. All right. Resize my canvas to 64 by 64. He's gonna get mad. My image disappears. Fantastic. All right, let's redo this. Can we control Z? He has to be in the center, if I'm not mistaken. Image canvas size 64 by 64. Yes, proceed. All right, cool. So this is my just one single image, right? And I would like to render this. So export this as a PNG. Export it here. And just call it player. This is just temporary. I just want to show you something. All right. So close this out. All right. So I would like to render this. How do we do that? Well, the first thing I need to do, right? So this is the initialization area. I'm going to keep it this way. I'm going to create a new area and call it the load area. Load and load. All right, so in here, I'm going to create a new texture. So SF texture. All right, and I'm going to call this player texture. All right, next, I need to create a sprite. SF sprite and player. I'm gonna call him player sprite. All right, the texture is the actual image. The sprite is the thing that we use to move the player around, rotate him, scale him, and so on and so forth. So the first thing I need to do is actually load my texture. So I'm gonna do player texture dot load from file. So load from file is a function, right? You can see that this function returns a boolean, so it's gonna return true or false, and it takes two arguments. The first argument is a constant string called file name. We'll talk about const later on. Don't worry about it for now. But the first argument is a string, which is the file name. Where can I find this file? What's the path to that file? And the second parameter, which I don't have to provide, I have the options of not providing, because you can see here it says equal. Whenever it says equal, I don't have to provide a second parameter. But the second parameter is the area. So I can load only a part of that texture, or just have only an area of it. So we're going to completely ignore that. We're just going to load the entire thing. So I'm going to do load from file. It needs to know where that is, right? So we're going to do a string. And I believe, if I'm not mistaken, how this is done, I could be wrong. So I need to go to assets / copy this entire path. So this is going to be a trial and error thing. I don't remember how to do this quite. So assets, player assets, and the actual asset name is player.png. Right? So that's my texture now. Semicolon, that's my texture. Now I need to assign the texture to my sprite. So I'm going to do player sprite dot set texture. And that will return nothing, return void, and it's going to take a texture and a reset rect, which I'm not sure what it is, but we don't have to provide that again because there's an equal to false, a default value. So for my texture, I'm just going to provide my player texture like that. Right. So I loaded my texture, right? And then I've taken the texture and I've set it to my player sprite. Now, remember when I said load from file returns a boolean? This boolean is true or false depending on whether this was loaded successfully or not. So what I can do is I can surround this entire thing in an if statement. And I can say, if this was loaded correctly, then I will set the texture, and I'll print even a message. I'll say cout player image loaded std and drop. Right? However, if it failed, so I'm gonna continue this with an else statement. And I haven't told you guys, I haven't mentioned an else statement. What's an else statement is? So you can have an if statement, and right after that an else. So if this condition is true, then I can do this. However, if the condition is false, I will execute this code. So that's what the else is, right? So in this case, if it's true, I'm gonna say player image loaded, and I'm gonna set the texture. If it's false, I'm gonna say player image failed to load. Image failed to load. Cool. So now if I press play, hopefully it will load correctly. Player image loaded. Fantastic. All right. So that worked, right? And this is the path of my image plus my image. What's my image, right? Which is great. Now I actually need to render it. So I'm gonna do window.draw player sprite. This is really important. Draw will take the player sprite, not the player texture. You cannot render, you cannot draw a texture. You have to draw a sprite. A sprite takes a texture, and you can only draw an actual sprite, right? So this is very important. If I try to draw a player texture, I'm just gonna get an error. It's gonna be like, hey, I can't draw this. Cool. So if I press play now, we have a sprite on our screen, which is super cool. Pretty exciting. All right, so I have my sprite, right? That's the easy way of doing this. And I can move my sprite. Now, let's do the hard way. Should we do the hard way? Well, not the hard way, but the proper way. I mean, right now, we need all these sprites for animation, right? Because we want to do animation. So, should I do this now? Let me think for a second. Should I do the... I mean, yeah, we can. Okay, I'm gonna load this entire sprite sheet. Right, so I'm gonna do a sprite sheet instead of player. Right, so I'm gonna press play. And this is my sprite sheet, right? Now, I only want to draw a part of it, not the entire thing. So only the first one. Okay, so what we can do, and the cool thing is, after I load my texture and I set my texture to my sprite, I can say dot set TextureRect. Set TextureRect is a function that basically allows you to put a rectangle on where you want to draw in the texture. So what that means, if I open this, basically set rect texture, what it will do is you will set a position and a width for this rectangle. You will say, I would like to put a rectangle over here in this position, and its width is this wide. The rectangle is this wide, and it's this high. Right? So that means only this part will be drawn. Now you can do it differently. You can say, okay, well now, you know what? I would like to set my rectangle over here, and I would like to draw the rectangle width will be this big, and its height will be this. So now only this part of the image is being drawn. You can do it even this way. You can say, I would like to set my rectangle over here. I'll pick a different color. Let's set my rectangle over here. Pick black. I would like to set my rectangle over here. I would like to draw this part. So now you're only drawing like part of him. So if I zoom in, yeah, this is much better. Zoom in. So I can say, hey, I would like to set my rectangle this big. So you're only drawing this area. So part of him is cut off. You can set the rectangle whatever you want. You can set the rectangle how big it is or small it is, which is cool. So how do we do that? Well, set rect, right, takes a rectangle, takes an SF int rect. An SF int rect is just a rectangle. It's a class. SF rect is just a class. So I'm going to do SF int rect, right? Rectangle is just a rectangle. It has a width. So rectangle has a width, height, x and y position, and width and height. That's what a rectangle is. An int rectangle, that means all of these four variables, all of these guys are integers. Because there is, I believe, a rect. Yeah, there's an rect class, which can be a float. So you can have a float rect, and you can have an int rect. In this case, this requires an int rect. Okay, cool. You can see this function, there are 6 versions of this function. So there's a version that takes nothing. There's a version that takes left rect, top rect, width and height. There's a version that takes and, which doesn't make sense to you now. We'll talk about that later. There's a version that takes an and, a version that takes a position and a size. This is a vector to I and a vector to I, position and size. And there's a version that takes whatever this is. Don't worry about it. So what we're going to do with this one. So the first argument is the left side of the rectangle, meaning the x-axis. Where do I want to have this rectangle? Well, I'm going to say 0. Next part. Next part is the top of the rectangle, also 0. The width of my rectangle is 64, and the height of my rectangle is 64. So because we did the math before. If I go here, we said that every single sprite in the sprite sheet is 64 by 64 pixels. So this is what I'm doing here. I am basically saying, take this image, put a rectangle at 0, 0. So this is 0, 0. And the rectangle width should be 64 and 64 down. So I'm selecting this image, right? So this is 0, 0, and 64 by 64. What if I want the second image? Well, let's do some math. We know that, well, before we do that math, let me just actually run this and so you can see it. So if I press play, you'll see now that I'm only drawing the first image, right? And you can see this is my first image over here, right? I'm only drawing this part of the image. What if I want to draw the bottom part of the image, right? What if I want to draw this one? Well, this is pretty easy to do again. If I zoom in a little bit here, I know that this is 0, 0, and the width and height is 64 by 64. So 64, 64, this is 0, 0. Okay? Now, let's do some math. If this dot is 0, 0, and this dot over here is 64, right? Because the height is 64. So this entire area is 64 pixels, right? So what would this position be, this dot over here? Well, if this is 0, and I'm going 64 pixels down, the x-axis didn't change. I'm still on, I didn't move to the right? I'm only moving up and down. So if the x-axis is 0, then this is the same position, so it will still be 0. So we didn't change the x-axis. However, we moved down 64 pixels because 0 here. This entire height is 64. So we moved 64, and this is 64. What about this? What about if I want to put my dot over here? Well, again, we didn't move anywhere on the x-axis, but this entire this entire height is 64. So 64 plus 64. So this entire 64 here plus another 64, that will give me this. 64 plus 64 is 128. All right, what if so this dot, this position here is 0, 128. What if I want this over here? Right? Well, again, so this is 64. This is another 64 and another 64. So what is 64 by 3? No idea. Let's do math. 196. 192. Damn it, close enough. All right, so now this is 0, 192. Right? What about this dot over here? Well, again, add another 64. But this would be the end of my image. So 0, 256. Cool? All right, so what if I want this image, right? What I want you to do, think about it. Relax. Take your time. Think about it. I'll give you a second. I'll give you 2 seconds. Cool. All right, let's try to do this. Well, pretty simple. So if I remove all of this, let's do some math. I said I want this image, right? All right, so 0, 0 is over here. I know that every image is 64 wide and 64 high. So let's count. 64, 164, 264, 364, 564, 564, right? And then I stop here. The reason I stop here because I want to start at this dot, like I want to start over here. So 1, 2, 3, 4. 4 multiplied by 64 is equal to 256, if I'm not mistaken. So 4 by 64 is 256. So now I know on the x-axis, this dot, that if I go all the way down, right, I know that this dot on the x-axis is 256. So now I figured the position of this on the x-axis, which is 256. 256. All right, let's figure it out on the y-axis. All right, so this is, again, on the y-axis, this is 0. Let's add 64. So this is the first 64. Let's add another 64. Another 64, and I want here, right? I want it to be over here. So I stop here. So that's 2 multiplied by 64. That's 256. What about this one? Well, 64 multiplied by 2 is 128. So now the position of this sprite is 256 by 128, right? And I can prove that to you, right? Let me try to prove that and see if it renders the correct image, right? So we're gonna put these values in our program. So the position is 256. This is where do I want to put the rectangle at? So I want to put it at this position, and I want to put it at this position at width and height. Sorry, x position, y position, and I want the rectangle to be 64 by 64, because I mean that's my image. It is 64 by 64. So where's my image? Right? I know that every single image, this never changed. Every single image is 64 by 64. But I want to start my rectangle at 256, 128. So 256, 128, and 64, 64 is where I want my rectangle, the width and height. So now if I press play, that specific image should be rendered. Right? I wish I can zoom this. I mean, I can. Let me change the scale. So I'm going to do sprite.scale equal to, scale is a function. It takes a SF vector to F. So SF vector to F. I'm going to set the scale to 2 by 2. I think it's normalized. So 1 and 1 is normal scale. 2 by 2 is double the scale. Yeah, it's double the scale. You know what? Let's do three times the scale. So 3 by 3, scale it at 3 by 3. So that means you take the original image, which is 64, and you multiply it by 3. Right? Let's see. Is this the same image or not? Where's my program? Right, let's see. Let's compare. Let me delete this. Does this look like the same image? Look at his hand. Yep. Right? His hand is at his, like this little bit bone, which is, this is a little bit higher. This is at the bone. This looks a little bit different. Look at his leg. Right? It's a little bit more forward. So yeah, that's this image. Cool. And that's how we can only render part of my sprite sheet rather than the entire sprite sheet. Okay. Now, how about we create a system for this? A really cool system, right? Rather than always calculating, instead of always calculating this math manually, let the computer do the math. How can we let the computer do the math? Well, what did we do here? We basically counted. We said 1, 2, 3, 4, and then 1, 2, 3. So 4 by 64 and 2 by 64. And that's how we found out the position of my guy. Right? So let's try it again. Let's pick another image. Let's pick a different image. So let's say this image. How can I find this image easily rather than doing all this math, right? So before, what we did is we did 64, 64, right? And we did all that. Let's do it a little bit faster this time. So what I'm gonna do, I'm gonna count on this image, right? So I'm gonna count this. We start counting from 0, right? I'm gonna start counting from 0. 0, because computers, they start from 0. 0, 1, 2, 3, 4, 5, 6, 7. Okay? And then let's count this. 0, 1, 2. Okay? So if I do, and I hope my math is not wrong, if I do 7 multiplied by 64, that means this position is at 448. Well, let's see. Let's see if I'm correct. 448. 64 plus 64 plus 64 plus 64 plus 64 plus 64 plus 64. So how many 64 do we have? 1, 2, 3, 4, 5, 6, 7. 7 by 64. There you go. 448. All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right? And if we do this, 1, 2, 0, 1, 2, or 1, 2, right? So 2 by 64, you get 128. So the position of this, right, is, well, whatever it was 0, it was 7 by 64, which is 448. Right? So literally what we do is just we count. We start counting, and we start counting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, where we want to be. 0, 1, 2. So this position, the position of this guy, right, is 7, comma 2. Multiply the 7 by 64, because we know every single one of these is 64. Multiply this by 64, and then we get its position. So rather than us doing this math, let the computer do the math. All we have to tell the computer is which image we want to render, right? We don't have to do all the multiplication. So let's do this. So instead of doing this, what I'm going to do is I'm going to say, I'm going to have two variables. Int x index equals 0. Int y index equals 0. Okay, so what's an index? An index is basically a number, right, that starts from 0. So an index is just a number, like a count. But rather than starting from 1, an index starts from 0. So we say 0, 1, 2, 3, 4, 5, 6. We start 0, 1, 2. We don't say 1, 2, 3. We do 0, 1, 2. So that's what an index is. It's just a number. Okay? So what I'm going to do, I'm going to here and say index, x index, multiply by 64. Right? And then y index multiplied by 64. And I know my image 64 by 64. So if I do 0, 0 over here, it's going to draw the first image. Right? It's going to draw the first image, which is over here. How does this work? How does this math work? Well, think about it. I'm saying here that the index is 0, right? Right now the index is 0. 0 multiplied by 64 is 0, right? And the y index is 0, so 0 multiplied by 64 is also 0. So I'm putting my rectangle at 0, 0, and we all know that 0, 0 is top left, right? What's next? So I'm setting the position there. What's next? Well, then I'm saying that the width and height of my rectangle is 64. And we always have the rectangle as 64 because we know that the width and height of all of these images are 64 by 64. They're all 64 by 64. So all we have to do is worry about where is this rectangle going to be positioned. Is it going to be positioned over here? Over here? Over here? So, but it's always 64. It's always 64. We just need to figure out where we want to position it in the world. And so we have a really neat system where we can just put the numbers here, figure out where it is in the world. And I can do that by counting. So let's say I want this image, the very bottom image. Okay, let's start. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So the bottom image is 8. So we put 8. Next, let's count. 0, 1, 2, 3. So this is 3 on the y-axis. 3. So now if I press play, it's going to render that exact image that I want. And he's looking to the right. Yeah? How does this work mathematically? Again, think about it. You have 8. 8 multiplied by 64, right? Equal to whatever it is. How much it is? It is 8 by 64. There's 512. 512. Let's see if this math is correct, right? What do we do to make this work? Well, we say this is 0. I know on the x-axis, this is 0. Forget about the y. We're just talking about x, right? So this is 0. We add 64. This is our first 64. Second 64. So this is 0. This 64. This is 128 over here, right? This is 192, right? Where this is right? Like that. These are the positions, 192. And then we add 64. I'm always adding 64, right? What's the next 64? Well, 192 plus 64 is 256. So this is 256. Next, add another 64. What do we have? Another 64 is 320. Another 64 plus 64. What do we get over here? 384. So add another 64. Right? What do we get? 448. Let's add another 64. Right? And we want to stop because we want to position our rectangle here. This is where we want our rectangle to be, the position of it, because we want it to have the width and height of a 64, right? So this is the point we want. Okay. So what is this now? The point is 512. Right, so this location is 512. Right? And this is, we did 8 times. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 by 64 is 512. And that's how that math worked. Right? And then we do the same thing on the y-axis. The y-axis is the same thing. So this is 0 over here. Right? On the y-axis, this is 0. We add 64. So this point is 64. We add another 64. This point is 128. We add another 64. This point is 192, right? So let's do the math. 0, 1, 2. 2 by 64 is 128. 0, 1, 2, 3. My apologies. 3 by 64 is 92. So now the position is 92. So this, now the position is 8, 3, which is 8 multiplied by 64. 3 multiplied by 64. And I get the position of 512, comma, 192. Right, this is the position of it. Right, so, and that's how that math worked. Right, we literally count from 0. We do 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3. So 8 on x, 3 on y. We multiply both by 64, and we get the location of my sprite. Right? Hope that made sense. Just a little bit basic math. There's nothing much to it, really. Right, so this is a really cool system. So we just take the index and we multiply by the height, the width and height of my image. That's where the position is going to be. And I know that the width and height of my rectangle is always 64. All right, take care. Have a good night. All right, so that's that, right? It's pretty simple. And so now we have that image here. So cool. So now we have a system, which is a cool system. Right? Now we can pick any image on my sprite. All right, so So the basic images that I would like to pick is this one when he's looking forward, this one when he's looking left, this one when he's looking down, and this one when he's looking right. But for now, we're just gonna pick 0, 0. Right? Just to make everything simple, we're just gonna do 0, 0 for everything. Right? Cool. All right, we did this code. Now we need to actually move him. Now to move something, we do it in the update loop. All right? We have another 25 minutes. I want to end the stream at like an hour and a half. I don't want to take too long. So the next part is actually moving the sprite. To do this, we need to check for keyboard input. That's the first thing we do. There's two ways to check for keyboard input. The first way is check it through the event system. The way we check it through the event system, if I'm not mistaken, I do if event.type. Actually, event.keyPressed equal to SF keyboard, gonna do W, right? So that means if the event is a key press, and if the key press is W, then I want to move my guy forward. Okay, so how do we move him forward? Well, it's really easy. We take the player sprite, right? We do dot set position, because we want to set the position of my sprite, right? So what is the position of my sprite is going to be? Well, to move anything in the world, we take the previous position and we add to it the new position. So for example, if I am over here and this my position is 0, 0, and I would like to go 1 unit to the right. So what do? I take the previous position, which is 0, and I add 1 unit to it, which is 1. So now I moved 1 unit to the right. I want to do that again. So I take the previous position, which is 1, and I add 1 to it. And now I moved 1 unit. Again, I take the previous position, 2, and I add 1 unit to it. That's 3. And so on and so forth, right? And if I keep doing that while pressing the key, I am moving forward all the time. And that's the entire idea. So the first thing we need to do is get the previous position. How do we get the previous position? Well, it's really easy. Player sprite dot get position. Get position is a function that is going to return an SF vector to F. Right? So this is the previous position, right? And it's a function, right? Get position is a function. This function is going to return an SF2F, right? And we know that an SF2F has both X and Y axes, right? So, hey Ian, no worries, take your time. So the position, right, it has both an X and Y axis because it's a vector 2F. A vector 2F has X and Y. So because this function will return an X and Y, I can do dot X or I can do dot Y. So not to confuse you too much, what I'm going to do is just going to store it in a vector 2F variable. So call position equal to get position, right? So get position is going to return to me a position, which is a vector 2F. And you can see here, the return type at the very beginning is vector 2F. And I'm storing that into a variable called position. So now, this is my previous position, right? I haven't updated my position yet. I just pressed W. So I press W, I'm getting the previous position, which at this point in time is 0, 0. Okay, so I take the previous position, and I add to it the new position that I would like, or how many units do I want to move? And I would like to move 1 unit. So vector 2F, like to move 1 unit to the right and 0 units down. Okay, so here's the thing. I press W. I start the game. I press W. My position is 0, 0. I get my position from this function getPosition, which returns a vector 2F. This vector 2F is being stored in a variable called position, which is over here. This will contain the values 0, 0. So I take 0, 0, and I add to it 1 unit to the right. Remember, this is the x-axis, right? And this is the y-axis. So I want to move 1 unit to the right. So 0 plus 1 is 1. If I keep pressing my keyboard and holding, this loop will happen again. So now my position moved from 0, 0 to 1, 0 because I moved 1 unit to the right. So now when I do get position, this will have the value 1, 0. 1, 0, I add to it 1, 0. Now it's 2, 0. 2, 0, I add to it 1, 0, 3, 0, 4, 0, 5, 0, 6, 0. And as long as I'm holding the key, this is gonna keep incrementing. And that's the entire idea of moving my player. Right? So now if I press play, this is W, right? Wait, hold on. W is up. This should be D, because on my keyboard, D is going to the right. I want to move to the right, not W. So sorry about that. So now, if I press the D key, I'm gonna press and hold the D key right now. Well, that was disappointing. That did nothing. Am I doing this wrong? Dot type equal. Type is an event SF type, so SF event type. Okay. Should be keyboard, right? Key pressed. Okay. Okay. So it should be if event type equal to SF event key press, right? If the event is I pressed my key, and then so if I pressed my key, I need to check what key I pressed. So if event dot key is equal to SF event key. How the hell do you? I'm just gonna look at the documentation. Let's go to the event section. Events explained. Thank you. All right, I check event closed. Okay, key press. So if the event is a key press, so if the event type is a key press, I want to check a specific key. Can I get a specific key, please? Oh, so if event key press, and then I do event code, event key dot code. All right, so event key dot code equal to SF keyboard escape. So in my case, it's going to be SF keyboard D. All right. So now let me do this. Put this code over here. All right. Let me explain this now. So first, I check: did I press my key? Right? If I pressed my key at all. So the event type. This is So this is my event. It has a type, right? And the type is a key press. Next, I need to check what key press I did. So my event has a variable called key. Key has a variable called code. The code of type SF keyboard. So in here I do SF keyboard D. So if I press a key and that key is the D key, then I should move to the right. So let's try this. If I press D, I'm gonna press and hold D now. All right, cool. So that worked. It's a little bit too slow. So maybe I'm gonna increase the unit jump, let's say by 10. So he's gonna move 10 units to the right, or 10 pixels. So this is pixels, by the way. I'm moving 10 pixels. Before I was moving pixel at a time, now I'm moving 10 pixels. So I'm gonna press and hold now. Okay, sorry, I pressed the wrong key. I'm gonna press and hold now. Okay. One thing I want you to notice, so he's moving, right? That's great. It's fantastic that he's moving. But notice what's happening. I'm gonna press and hold. Look at him. I'm gonna press and hold now. Did you see that? He moved a little bit, stopped, then he moved again. Let me do this again. Okay, I'm pressing and holding, right? This is really important. I'm pressing and holding. Look at him. He's gonna move, stop, and then move again. I'm gonna press and hold now. You see that? He moved and stopped again. Moved a little bit and stopped, and then moved again. I'm gonna hold now. See? See? See how he stops a little bit? That's bad. That's not smooth. That's really not nice, especially when we're making our game. Why does this happen? Why does this happen at all? Well, it's because of Windows. Windows is dumb. Windows is very dumb. Well, not really, but it's how Windows work. Okay, let me explain this. So here's the thing, right? Here is the thing. Whenever you press a key on your keyboard in Windows, even if you're holding it, so let's say I press the D key or the W key. Let me say I press the W key and I'm holding it. With Windows, when you press a key, it's gonna register as that you pressed a key. So this is a key press, a single key press. Even though you're currently still holding, you're still holding the key. The first time you do it, in Windows, it registers as a single key press. However, after, let's say 10 milliseconds, I don't know the exact time, let's say 10 milliseconds, or it feels like longer than that. Let's actually say 250 milliseconds, right? So that's a quarter of a second. A second is 1000 milliseconds. So this is equal 1 second. Okay. Half a second is 500 milliseconds. That's equal 0.5 seconds. Right? A quarter of a second, so 0.25 second, is 250 milliseconds. Right? So the first time you press the key, let me put that back. The first time you press the key, it registers as a key press. After around 250 milliseconds, I don't know the exact number, but let's say it's 250. After 250, if you're still holding the key, Windows now is registering that you are holding the key. So now it's firing rapidly. It's saying, hey, you're holding the key, you're holding the key, you're holding the key. So that's why the first time when you press the key, it registers as a single key press. So now we just moved 10 pixels and then it stops. After 250 milliseconds, it's like, whoa, what's going on? You're still pressing the key. Hurry up. He's pressing the key. Move him. So he moves him to the right. Right? But this pause is really, really ugly. The 250 millisecond pause here until Windows registers that we're actually still pressing the key. That is really bad. That's really ugly. Right? And we don't want to do that. We don't want to do that at all. So that's what happens if you handle your movement with events. If you handle your movements with events, then, well, that's gonna happen, right? We don't want to do that. And that's why specifically, whenever we're writing code for movement, we don't want to touch the event queue at all. We don't want to touch the event loop at all. So this code now is garbage. So I'm gonna comment out all this code. Not good code, bad code, ugly code. Well, actually it was pretty nice code, but it just doesn't work very well. So now, instead, I'm gonna do this outside the event loop. So this is my event loop, right? Outside it, I'm gonna say if SF keyboard is key pressed, and this is a function, okay, that takes the key that I just pressed. So in this case, SF keyboard D key. So if I pressed the D key, I'd like to do this code. All right. Now I'm gonna show you. I'm gonna enable both code, but this time instead of D, I'm gonna say F. So with the F key, he's gonna move to the right with events. With the D key, he's gonna move to the right without events. All right. So let's see the difference. I'm just going to do the events, the regular one. So I'm going to press F, right? So F is, let me reduce this. So F is the event, right? F is over here, the event. Let's do this. Press F, pauses, moves. Pauses, moves. Not good. All right, let's do D. I'm going to press D now. Did you see that? One, he moved really fast. Two, he didn't pause. So we need to reduce the speed to like 1 pixel. All right. So let's do this one more time. I'm going to press F. He pauses, then he moves. I'm going to press D now. See how smooth that was? Restart. See how buttery smooth this is? It's really, really nice. So super smooth. Okay, so that's great. So now the question is, why does he move? Why do we need to move more pixels in the event? Or why does he move slower in the event system than here? Well, here's the thing. There's a specific pull rate. A pull rate is a rate in which we check our queue. And the rate where Windows is going to add an event into that queue. And because the pull rate is low, because if the pull rate was high, if we're always checking that queue, that event queue, if we're always, so let me draw this. If we're always checking that event queue, so this is my event queue over here, right? And let's say we're checking my event queue every 10 milliseconds. So every 10 milliseconds, I look here and I check there's an event. And then another 10 milliseconds passes by and I check there's an event, right? If I do that every 10 milliseconds, then that's not a big deal, right? The application, I don't like it's expensive to go check my event queue every few seconds, right? Or every millisecond, every few milliseconds. You don't want to have this running like all the time. You just so your application doesn't use a lot of CPU resources, right? Because normal applications, they don't care. Normal applications, they want to use as little CPU power as they want. But we're making games. Games need to run and take the entire resources of your computer because we want it to run as fast as possible and as smooth as possible, right? So the pull rate, every time we check the queue, there's an offset, not an offset. There's a specific timer when we check the queue, right? And let's say it's 10 milliseconds. So every 10 milliseconds, we check the queue. Every 10 milliseconds, we check the queue. And that's why, so I check every 10 milliseconds and I move 10 pixels. And I wait. After 10 milliseconds, I move another 10 pixels. After 10 milliseconds, I move another 10 pixels. Let's say this is actually not 10 milliseconds, let's say 25 milliseconds. So every 25 milliseconds, I'm moving 10 pixels, 10 pixels, 10 pixels, 10 pixels, right? And so that's why there's a delay, right? Because we only trigger this every 25 milliseconds. But this is dependent on our frame rate. And I bet you anything that my frame rate is running at 2000 frames per second right now, right? It's running super fast. And that's why this is going as fast as humanly possible. And I wish I have I don't know how to check the frame rate for my application. Like before, if I wanted to check the frame rate, I would use something called Fraps. And do I have Fraps here? No, it's a dead application. And I know there's a newer application where you can do it, but I don't remember it. It doesn't matter anyways. Later on in the future, we're gonna display our frame rate, the game frame rate in the game itself, right? But I bet you anything that my frame rate is at 2000 frames, right? So that's why he's running as fast as possible for the frame rate. Even if my frame rate is locked at 60. 60 frames rate is still faster than the event loop, so he moves faster. So my movement code is now dependent on how fast my game is, which is not good. Because if I'm running the game on a slow computer, my movement speed is going to be really slow. If I run it on a faster computer, my movement speed is going to be super extremely fast to the point where it can be unplayable. So it's not very good that this movement speed is tied to my frame rate, but we'll talk about that later. The point that I want to mention here is that this code over here right? The reason I have to move 10 pixels and it's slow, and 1 pixel here and it's super fast, is because we're only checking this event loop every, let's say, for example, I don't know the exact time, but let's say, for example, we're checking this every 25 milliseconds. So we check, we move 10 pixels, and then we pause for 25 milliseconds. We move 10 pixels, and then we pause. Where this is like, go, 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 every single frame. Go as fast as possible. Move one, move one, move one, move one. This, check, move, wait, check, move, wait, check, and so on and so forth. So that's why we have to move more pixels every event loop, every time we go through that loop. Where here we're moving super fast, so we have to reset it at 1, right? So that is kind of the idea. So we don't want to keep our movement code tied to the event loop. We want to keep it outside the event loop. So this code is bye-bye. Ow, sorry, I hit the mic. All right, so with that in mind, that means that now I can move my code, or I can move my guy to the right, which is great. What if I move him up, down, right, and left? So as an exercise, what I would like you to do, think about this as an exercise. I would like you to move this character right, left, up, and down. You can pause the video here, seeing that you're probably watching this as a video. All right, and go. All right, cool. So I don't know if you did it or not. I assume you did, hopefully. If not, let's do it together. So I'm going to copy this code, this exact same code. I'm going to copy it, and I would like to press A. A means he moves to the left. All right, look at this. Before, I'm saying take the position and add to it 1 on the x-axis. It means I move right. And remember here, from our graph, the positive x-axis is moving to the right. What about the left? Where if I want to move to the left, I need to go negative on the x-axis. So it means this 1, instead of 1, I'm going to do -1. Either I do -1 here, or I keep it at 1, and I do minus like that. Either of them work, because I'm still subtracting 1 here, or I'm adding a -1, which is still subtracting, right? So both of them work. So let's try this now. So I'm going to move right, I'm going to move left, right, he moves right, he moves left, he moves right, he moves left, he moves right, he moves left, he moves right, he moves right, he moves right, cool, he's moving. All right, let's do up and down. So we're going to do D, sorry, we're going to do W. All right, now W is the y-axis. And remember, if I want to move up, look at the graph here. This is the positive y-axis, but this is the positive y-axis in mathematics. In Windows, remember, we said up is negative. Okay, so we have, if I want to move up, I need to go minus y-axis. So 0, -1 if I want to move up. All right, let's do down and do S. And now if I want to move down, look at my graph. Down is positive y. So I'm going to do +1. So S is down. W is up, -1. Right is +1. Left is -1. So now I have all directions. If I press play. Hello, Brett. If I press play, I move right, left, down, up, right, left, down, up. And I can move in all directions, which is super cool. So now I have movements, which is awesome. All right, I can still make my code a little bit better. Notice here what I'm doing. Every single time I check my if statement, I'm getting the previous position, then setting it. Getting the previous position, then setting it, right? And so on and so forth. This line is different from this line, which is different from this line, which is different from this line, right? Like all of them are slightly different because 1, 0 here, it's -1, 0, 0, -1, and 0, and 1, right? They're all slightly different. However, this line is always the same line, right? It's literally identical every single time. So I can reduce the amount of code I'm writing here. Rather than duplicating this code 4 times in every if statement, what I can do is take this code, move it at the top, right? So I get the position first, and then if I press the D key, I move him. If I press the A key, I move him. If I press the W key, I move him. If I press the S key, I move him, right? So now I only need to get the position here at the very top. I only need to get it at the very top. And it doesn't matter which key you're pressing, I have the position saved here, which is great. So now if I run this, it should do the same thing, right? Yeah, it's doing the same thing, which is great. Now my code is a little bit cleaner. Now, one more thing. If an if statement has a single line of code, you don't need to add 2 curly braces. You can get away with doing this. And I'd like to do this because it's a little bit nicer, a little bit cleaner. So now the if statement will execute the line immediately under it. If there are 2 lines like that, right, that means the if statement is only going to take effect on this line and not this line, right? Only this line, not this line. If you want the if statement to take effect for 2 lines or for more than 1 line, you have to put the curly braces like this. Like so. Cool. But since there's a single line of code, then I can get away with doing this, which is a little bit nicer, a little bit cleaner, in my personal opinion. You don't have to follow this if you don't like it, right? It's a preference, it's a programmer preference, which I kind of like. It's kind of compact like that. So I'm getting my previous position, and if I press D, I take my previous position and I add 1 to it. Previous position, add -1. Previous position, add -1. Previous position, add 1. Now it should work fine. So there you go. No, I'm not streaming on Twitch, only YouTube. Alright, so here's my character moving in all directions, which is awesome, right? Alright, it's been an hour and a half, right? I want to keep these videos as an hour and a half rather than 3 hours like yesterday. It was very exhausting, right? So for now, I'm gonna call it a day. What I'm gonna do, I'm gonna commit my code, right? It's very important, remember, at the end of your day, commit your code and push it, right? So create your own repository, by the way. So I'm gonna commit, first of all, I would like to delete this image. So this player image, we only need the sprite sheet. So, right? So I'm gonna, you can see the sprite sheet is using LFS, right? And then I'm also gonna commit my code. All right, let's look at this a little bit. You can see here, there's a green icon. Whenever you see a plus green icon on a file, that means this file has been added for the first time ever. Whenever you see a yellow icon with 3 dots, that means that this file has been modified. It was previously added, but now it's been modified. And you can see here that's modified. Any red lines, those lines are deleted. Any green lines, those lines were added just now. All right, so you can see there's a bunch of red lines which we deleted, bunch of red lines which we deleted, bunch of green lines which we added, bunch of red lines which we deleted, right? So it keeps track of our history. What was deleted, what was added, right? So I'm gonna stage everything, right? I'm gonna add the title, added player movement, and in detail, I'm gonna say added player sprite sheet, added movement code for the player. All right. So now, it's kind of cool, right? I added. It's a little bit more detailed, which is nice. So now I commit my code. I stage it first. I add the comment and the title. I commit it, right? And notice here, it says dev. There's 1 arrow, right? So the 1 arrow here means that I haven't pushed this code online. There's a single commit that I haven't pushed online, and the arrow is pointing up, meaning push. If it's pointing down, it means pull. It means there's code you haven't pulled from the cloud. Now this means that there's code, which is the new commit that I did, that I haven't pushed online. And notice here that origin dev is origin means online, right? Whenever you see the cat, that means it's the online cat or the cloud code. So the code on the cloud for dev is on this commit. The code on the cloud for master is on this commit. The code cloud on build is on this commit. So the cloud only has this commit. My local machine has this commit. How do I know that? Because I can see dev, there's no cat icon next to it. Whenever you see a bolded text here, that means I am on this commit currently, right? I am on this commit, which is locally, but this commit is currently on the cloud. All right, so I would like to push my code. You can see there are 2 commits now. Now I'd like to push my code to the cloud. So I'm just going to click on push, and then I'm going to click on push. So now the cat, this origin dev cat should move up here. You can click on here to see more detail. Right, but I'm going to close this window because I want you to see that this moved now. You can see now the cat, it moved from here to here. So now here's the thing. The master branch and the build branch, they have this commit on the cloud, right? But the dev branch has the latest commit, which is over here. So remember when I was mentioning and I was saying how that sometimes you can have commits in different branches. So the master branch has this commit. The div branch has this commit, but the dev branch has my new commit that I just committed. And a commit is just a single save point, right? And you can see that the previous commit, it has my author, my picture, my name, right? It has the title and what I did and all the code that I committed. In the new commit, you can see there's much less stuff that I added, right? Because before, you can see all this. I added all the include libraries, all the libs, we added a bunch of things. But our new commit only has 2 files changed. I added an image, which is my Spritesheet, and I added a little bit of source code. And this is the title and the description. So there you go. That's pretty much it, right? So now my code is pushed. You can check it out if you'd like. But there you go. That's where I'm gonna end the stream. Thank you very much, guys, for coming along, and I will see you hopefully tomorrow. Tomorrow we will do some more movement. We'll add an enemy tomorrow. Tomorrow we'll add an enemy and shoot him and kill him. All right. See you guys tomorrow.